video is about experiments with waves. Apologies for the voice, I have laryngitis currently. Okay, there are three main ways that waves can interact with their surroundings, and you need to know all of these in your P1 exam. The first one is reflection. So you might think you know what this is from just basic science, but you need to know some rules about it. So it occurs when any wave that isn't just light comes into contact with a medium. Okay, so that's any surface basically. Some of the wave or all of it will be reflected off of that surface depending on what the surface is. This is called a ray diagram, and you need to get used to drawing these. So you can see here you've got a light ray represented by a straight line, and then here would be a longitudinal waves like sound waves. Now this is your surface. Whenever a wave comes in and hits a surface, you have to draw a normal, and the normal has to be 90 degrees to the surface. Okay, it's really, really important. The incident wave or ray is where it comes in, incident, and the angle from where it hits the surface to the normal is called the angle of incidence. Where it comes off is called the reflective wave, and then here is the angle of reflection. Okay, there's a law you need to know, and that is, the fact is a law means it happens all the time. So the angle of incidence is always equal to the angle of reflection. Okay, it's really important that you remember that and use it within your questions. Another thing you need to know about reflected images is that images and mirrors are always the same way up, so upright, but they are flipped, which we call laterally inverted, and they're also virtual. Okay, now virtual means that the image cannot be formed on a screen, or the image is formed behind the mirror. So they may give you something like this in an exam. So if you were looking in a mirror, you would see the image here. It's a virtual image of a camera. I'm going to show you an exam question now about what they might ask. So here's the exam question. I'm going to do it on here. So a student holds a wristwatch in front of a plane mirror. The student can see the image. The diagram shows the position of the wristwatch and the mirror. So this is worth 4 marks in an exam, so it's quite a lot of marks to lose. They've given you the wristwatch here and the plane mirror. Now the cheats way would be to measure the distance from here to here, and that's where your image will be produced. But you won't get all the marks for that, you need to show it. So what you do is, light will be reflected from the wristwatch. So shown by an arrow like this. Now it's really important there that you draw your normal. Now you can take a protractor into the exam if you want to, or just judge by eye the angle of the reflected ray. Now you need 2 of these, so we'll do another one here. I'm going to make it a wider angle. Again, I need to draw my normal. Comes off, looks about right. And then you've got to trace back these 2 angles, these 2 rays, sorry. So if you trace them back, and then trace this one back, hopefully if I've done it right, they should intersect. Okay, you see they intersect here. So this is where the image of your wristwatch would be. And I want to check that, it should be right. Might be a little bit off, but that would get me all 4 marks there. And then it says the image of the wristwatch is seen is a virtual. Why is a virtual image? I love to ask this. So I'd say image cannot be formed on a screen. Okay, so if we go back to the slideshow, you see here it says 1 ray drawn from the wristwatch to the reflected would be 1 mark. 2 rays drawn from the wristwatch reflected mirror with I equals R for both rays, which I did. 1 ray traced back behind the mirror, I did 2. and then the image in the correct position. Okay, so that'll be all for works. And here's for the virtual image. Cannot be formed on a screen, or rays of light seem to be from but not pass through it, or except image formed behind the mirror would be fine as well. So refraction, a bit of a hint there, is when waves come into contact and then travel through a different medium. So medium is just a material, so a gas, a solid or a liquid. They become refracted. Now they do this because mediums have different densities. So it means that they change their speed. If they come to a more dense, when it's light, they will slow down. Now because they slow down, they will bend towards the normal. If they were to go into a less dense material, it'd speed up and bend away from the normal. That's for the EM spectrum waves. Sound's different. Sound travels better through a solid, so that would speed up through a solid rather than slow down. But that is what refraction is. Now, this is a refracted diagram. You can never know this angle exactly in an exam without knowing what we call the refractive index. And that comes up in P3. So for P1, you really don't need to worry about it. So an exam question for this one might be this. So it shows you here that a student investigated refraction, light passes through a clear plastic block. It's actually given you one there already. And then it says diagram 2 shows the same apparatus, use a ruler to draw. This is 2 marks, okay? It's really simple. Now like I said, you're never going to be able to know this angle. But because it's gone into a different medium, I know that it's changed its speed. Okay, it's gone into a denser one, so it's going to slow down. So as long as my line is less than this one, that will be fine. So I draw my line to there, direction arrow, draw a new normal, and then because it's going back into the same medium, air, it will travel out parallel. So you need to make sure that your wave coming out is parallel. A ruler is imperative here, okay? And then that should be 2 marks. So it says there, as long as, as long as R is less than I, that's fine. And then the refractive wave, correct command about 2 rays in the air are parallel. 2 marks. Okay, the next one is diffraction, okay? Another little hint. Whenever a wave passes through a gap or moves around an obstacle, it spreads out, okay? That's diffraction. It happens in light and it does happen, so it happens in longitudinal waves and in transverse waves. It happens in both of them. So light, and it does happen in sound. So here you've got the rays going through a gap and they become like a semicircle. And it can also happen around an obstacle. So it would carry on normal where it could, and it would diffract around there. So another thing that comes up is the size of the gap and the wavelength of the wave affect how much diffraction takes place. The best diffraction takes place when the gap is similar or the same size as the wavelength of the wave going through it, okay? That is asked in exams sometimes. Here's some everyday examples. So a little cove with some water or around a hill. If you were, say, here, you wouldn't get a signal from this tower, okay? So here's an exam question for diffraction. The diagram shows waves, water waves in a ripple tank move towards the gap of the barrier. The water waves diffract as they pass through the gap. Complete the ray diagram. Okay, so I'm going to try and keep them the same distance apart, but it would be like this. So semicircular waves drawn. They don't need to be fully semicircular. See here, semicircular waves drawn, judged by eye, do not need to be full semicircular, ignore any rays. They then could also ask you maybe there's a gap in the door, why would you hear a sound but not necessarily see the light from the TV? Again, it's all about maybe the door, gap of the door is similar to the size of the wavelength of the sound, whereas the wavelength of light is a lot smaller, so not a lot of diffraction would take place there. I hope this has helped. Thank you.